Today we're going to talk about the algebra and trig method of vector addition. So I'm going to show you a 6-step process for that. And as long as you follow the 6 steps, you're going to get the correct answer. So a student walks 8 kilometers at 28 degrees west of north, and then 5.8 kilometers at 48 degrees south of west. Find the student's displacement, meaning find the resultant, both magnitude and angle. That's what we want to find. All right, so let's set this up. So the first step in the 6-step process is draw a diagram and label it. So I'm going to go ahead and do that. I'm going to start by drawing an X and a Y axis. So right here. There's my X and my Y axis. And I'm going to go ahead and label these north, south, east, and west. And you don't have to do that, but for illustrative purposes, I'm going to go ahead and I'm going to do that. Right? This is going to be the origin right there, and that's where I'm going to start my diagram. And the first vector is 8 kilometers at 28 degrees west of north. So I want to go west of the northern direction. So there's the northern direction, and I want to go west of it, and I want to go 28 degrees west of it. So 28 degrees west of it. So I'm thinking right around there. So that's about 28 degrees. So I'll call that theta sub 1, and that's 28 degrees. A little arrowhead on there. And x sub 1, 8 kilometers. So that's my first vector. Then I'm going to draw another x and y axis at the tip of that vector. And my second vector is going to be 5.8 kilometers at 48 degrees south of west. So here's west, and I want to go 48 degrees south of the western direction. So I want to end up doing this. And that's about 48 degrees. So I'll call that theta sub 2, and that's 48 degrees. And then x sub 2, 5.8 kilometers. Now those are my two vectors, and I want to add those together. So this is where I started. This is where I ended up. So I'm going to go ahead and I'm going to connect them up with a dashed line. That dashed line represents my resultant. And that's the magnitude. This is going to be my direction. So that's going to be theta sub r. And I'm looking for both the magnitude and direction of that resultant. So that's step 1. Draw a diagram. Draw and label a diagram. That's step 1. Step 2, we're going to resolve each of these vectors into its x and y components, because ultimately we've got to create a couple right triangles. So we want to resolve these vectors. Here's the one vector. I want to resolve that into its x and y component, and I want to resolve this vector into its x and y component. Now when I create my right triangles, I like to include my angle in the triangle that I actually make. So let me show you what I mean by that. So I'm going to use blue, which hopefully will make this a little bit easier to see. Here's my first vector, and I need to create a right triangle using this as my hypotenuse, and that's my angle. So I want my right triangle to include my angle also, and I want to find the horizontal part of this and the vertical part. So there's the vertical part, and here's the horizontal part. Horizontal part goes from here and extends horizontally until it's even with where the vector started. So what you're going to end up with, and I'll use a blue dashed line, that's my y component, that's my x component. So I want to find those two components. Now let's do the same thing with the other vector. Here's the hypotenuse of that vector. Here's the angle. So I want to create a right triangle. I want to find the horizontal part of this, which is this right here, and I want to find the vertical part of this, which is this right here. going to be the y component. This is going to be the x component. So I need to find those x and y components. And we'll explain why in just a bit. So let's go ahead and start with the first vector. This is my angle. This is going to be the opposite side. So the opposite side is going to be the horizontal side here. So I'm going to go ahead and I'm going to put in x. So I'm looking for that horizontal side. And I'm going to use the trig function sine to do that. So sine theta equals opposite over hypotenuse. Now, that's the opposite side. I've got the hypotenuse, that's 8 kilometers, and I've got the angle, that's 28 degrees. That's why I chose that trig function instead of cosine, instead of tangent. I chose sine. Now I'm going to go ahead and substitute. So sine 28 degrees equals the opposite over 8 kilometers. Now I go ahead and solve for the opposite side, which is this x component. So I'm going to take the sine of 28 degrees and I'm going to multiply that by 8. And when I do that, I end up with 3.75. So 3.7558 kilometers. So I'm going to go ahead and underline that. That's important information. Now I'm going to do the same thing for this second vector. So I'm going to go ahead and I'll do that right now. Now look at this second vector right here. Look at, I'm trying to find this x component. This is my angle. This is my opposite side over here. The x component of this vector is the adjacent side. So in order to find that x component, I got to find this adjacent side. So in order to do that, I'm going to use cosine theta equals adjacent over hypotenuse. So cosine 48 degrees equals the adjacent, which I'm looking for, over the hypotenuse of 5.8 kilometers. And then the adjacent side is going to equal 3.8810. So 3.8810 kilometers. So I found the adjacent side of this vector and the adjacent side of that vector. Now, let me go back and find the y component. So let's go back to this blue triangle right here. And I want to try to find this y component right here. That y component is the adjacent side. So in order to find that adjacent side, that y component, I'm going to use the trig function cosine theta equals adjacent over the hypotenuse. Cosine 28 degrees equals the adjacent over 8 kilometers. And that is going to turn out to be 7.0636 kilometers. And I'll go ahead and I'll underline that again. Now let's do the same thing for this y component right here. Now this y component is going to be the opposite side. So I'm going to have to use sine to figure out that opposite side. So opposite over hypotenuse, and sine 48 degrees equals the opposite over 5.8 kilometers. And that opposite side is going to end up being 4.3102. 4.3102 kilometers. So now I have successfully resolved both vectors into their x and y components. So that's going to be the second step. Resolve. So that's going to be step 2. Diagram step 1. So step 3 is we're going to make a data table. And we're going to add up our x's and we're going to add up our y's. Oh, we're going to add up our x's, and we're going to add up our y's. All right, so let's go ahead and do that. So right here, x and y. Now, I've got to be careful here. I've actually got to define what directions I want to make positive and what directions I want to make negative. And it really doesn't matter. So it looks like overall I'm going to the left. So why don't I make to the left positive? And it looks like I'm going up more than I'm going down. So I'm going to make up positive also. And that means obviously to the right and down are going to be negative. That is important to do. That's a common step that's where mistakes are made. All right, so this is going to be step 3. And we'll call that data table. What we're going to do is we're going to add up all the x's and we're going to add up all the y's. So this x is going to the left. So I made to the left positive, so I'm going to put a positive 3.7558 in there. Now let's look at the other x. That's this x component right here. It's also going to the left, and I made to the left positive. So again, I'm going to put in a positive 3.8810 kilometers in there. Now let's look at the y components. So this y component is going up. I made up positive, so I'm going to put a positive 7.0636 in there. This y component is going down. So down is going to be negative. So be careful here. Negative 4.3102. Now I want to add these up. I want to add up my x's, I want to add up my y's. So when I do that, I get 7.6368. And when I add up the y's, basically I'm subtracting here, is 2.753. So I'm going to go ahead and circle those because those are going to be important numbers. So these x components are going to equal that, and these two y components are going to basically equal that right there. And what I'm going to do now is using this x component and that y component, I'm going to draw a new triangle. So that's going to be step 4. Draw new triangle. All right, so I'm going to draw an x and a y axis. That's my origin. That's where I'm going to start. According to this, that's a positive number. Remember, I made to the left positive, so I'm going to go to the left that far. So let's say that represents that number right there. Then I'm going to go ahead and I'm going to label it. So x equals 7.6368 kilometers. Then the y. Always do the x first and then the y. And go to the tip of the first vector, and that's where you're going to draw this y component. So at that tip right there, you're going to draw that y component. Now it's a positive number, and positive is up. So I'm going to go up that far. Now that number is a little less than half of that, so that's kind of what I'll try to draw here. So that's going to be my y component. So 2.753 kilometers. And there's my little dot, there's a little dot, and I want to connect those up. And that is going to be my resultant. That's what I'm looking for. I'm looking for that magnitude. And then the direction. Usually we like to make the directions relative to the x-axis, so I'll do that here, but you don't have to. But I'm going to do that. It's a good way to do it. So theta sub r. So we're looking for that angle right there. And this should be a more precise version of this right here. Can you see this? This is the vector we're looking for. That's what we're looking for. And then this would be the y component right here. And then this would be the x component right there. So now that I've got the x and the y components of my triangle, I can now go ahead and try to figure out the magnitude and the angle. So how am I going to figure out the magnitude? Well, I've got the x component and I've got the y component. So I can actually use Pythagorean theorem. So I'll go ahead and do that. That's going to be step 5. Step 5, Pythagorean theorem. Pythagorean theorem. So c squared equals a squared plus b squared. And these are both legs. Doesn't matter which one I make a and which one I make b. Remember, I'm looking for c. That's the hypotenuse. So I'll just put a, I'll make that the x component, 7.6368 kilometers. Square it, plus 2.753 kilometers. And I'll square it. Take the square root. And then I'm going to round off to 2 significant digits because I've got 2, 2, 2, 2. This is all multiplication and division, so we'll kind of go to those rules. So I'm going to end up with 2 significant digits. And when I do, it rounds off to 8.1 kilometers. I'm going to put a box around that. So from here to here, that's 8.1 kilometers. Or from here to here, 8.1 kilometers. Now that's the magnitude. I got to figure out the direction because every vector has a magnitude and a direction. So let me go ahead and do that. That's going to be step 6. So step 6, I'm going to squeeze it in here. Step 6, and this is find angle. So in order to find the angle, right, that's it right there. That's what I'm looking for, the angle. And I've got the adjacent side and I've got the opposite side. So I can go ahead and use the trig function tangent. That's typically what we'll use. So tangent theta equals opposite over adjacent. Tangent theta, the opposite side is 2.753 kilometers over the adjacent side, 7.6368 kilometers. And then I find that angle. So it's this divided by that, get a number, and you want to take the inverse or arctangent of that. Right? So on most calculators, you're going to take the second tangent. Some students call it the second tangent. You want to take the second tangent of that and make sure you're in degree mode for this. Right, so when I do that, I come out and I'm going to round off to 2 significant digits. I'm going to get 20 degrees. But right now that 0 is not significant. So I'm going to go ahead and I'm going to put a decimal point there to make it significant. So 20 degrees. I could also write that as 2.0 times 10 to the first degrees. I could write it that way too. Now we're not quite done yet because 20 degrees means 20 degrees above the positive x-axis right here. Well, we're 20 degrees in the other direction over here. Now I can't put negative because that's down here. That's below the positive x-axis. So what I'm going to do is, this is west, this is north of west, so that's what I'm going to call that, 20 degrees north of west. North of the western direction. That captures this angle. Right, that's going to be it for this problem.